In this video, we're going to be taking a look at the direct drive extruder kit from Microswiss. Now this kit was intended for the Creality CR10 and Ender 3 applications, and if you have one of those printers, you can definitely follow along because I'm going to be following the general guidelines and instructions directly from the Microswiss website. However, I'm going to be installing this on a ANET ET5X printer, and the purpose of this video is to show you, of course, the installation process, but to also show you that you can install this extruder kit on something other than the Creality applications. And so a lot of these Chinese printers follow a very generic sort of configuration, and this ET5X is very similar to the CR10, and so it has the 2020 extrusion on the X profile here on the x-carriage, and so that's what this kit was intended for. So if you have a printer that follows this similar sort of configuration, chances are this kit will work for you with a little bit of extra work. And I'm going to show you what's required and the problems that I ran into and how I solve those problems. And so any 3D printable files that I've provided will be down in the video description. You'll find links down there. And so let's get started with this installation. So we'll start by taking a look at the kit that I got here, which is the Microswiss direct drive extruder for the CR10 and Ender 3. And since I'm doing this upgrade on the ET5X from ANET, it is most similar to that CR10 construction. The Microswiss kit is a really complete kit, even has some spare parts, and that machine carriage plate is beautiful. Also in this kit, you'll find this machine tensioning arm, a steel nozzle, a bunch of hardware, the remaining pieces for the tensioning assembly, an extension cable for your stepper motor, the heat sink and heat break, which is also a really nicely machined piece, the heater block, a 3D printed filament guide, a sock for the heater block, some tools and other assortments of small pieces. And finally, there's a QR code for the Microswiss instructions. And so as I mentioned, this ANET ET5X is more or less a very close relative to the Creality CR10, and a lot of these Chinese printers are ripoffs of one another, and so the overall construction is very similar. A lot of these printers use the 2020 extrusion on the x-axis, and so the carriage is this sort of generic looking carriage that carries the printhead across the x-axis, and it's covered by one of these shrouds that looks very similar to the Creality shroud. And so the Microswiss plate should fit over that 2020 extrusion, since that's what it's designed for, and the 3 V-slot wheels will ride along that extrusion just like it would on the CR10 or Ender 3. I'll begin disassembling the hot end by removing the part cooling fan, and this part cooling fan comes off with 3 M2 socket head cap screws. Once you remove the screws, the fan duct at the bottom should also slip out of the blower fan, and you can put that aside. Next, the fan guard gets removed with 2 M3 socket head cap screws. Once you get the fan guard off, be careful not to pull on it too hard or too violently, as the wires for the heater cartridge and thermistor could be tugged on by this fan guard. And you don't want to pull on those because those wires can be a little bit brittle, especially those thermistor wires, which are usually quite small, and you don't want to damage them. On the back of the ET5X, there is this hot swap board where you can unplug the wires going to the hot end. So I'm going to go ahead and do that now. If your printer does not have a board like this that is a intermediate between the control board and the hot end, you might have to go directly to the control board and start unplugging those wires. Of course, you're going to be doing all of this with the printer off. Now we can go back to what's left of the hot end, and you can remove the 2 M3 screws on the heatsink, and that should completely remove the heatsink and heater block assembly. With the assembly removed, we can now much more conveniently work on it on our bench, and we're going to be reusing the heater cartridge and thermistor on the new direct drive unit, so we have to remove it from the old unit. And on most of these generic Chinese printers, these heater cartridges are retained with a grub screw or 2. In this case, there's 2, one on the bottom and one on the side. So you're going to loosen those off, and that should get the heater cartridge to slip out of the heater block. The thermistor is, in this case, retained with 1 screw on the side, and so I can also go ahead and remove that. and the assembly should come out now. Once you get those two parts removed, take a look at your wiring harness, as you may want to cut any zip ties or unclip any wire retaining pieces, as you don't want the heater cartridge and thermistor wires being tugged on in any way. These parts have been through a lot of heat cycles, and sometimes the wires become brittle and you don't want to crack them or rip them or break them in any way. The ET5X comes with an auto bed leveling sensor, and it's held onto the fan guard with two M3 screws on the side, so I'm going to undo those. Now, in a previous video, I showed you how to remove your auto bed leveling sensor and use a mechanical switch instead, which I find to be much more reliable. And if you guys want to check that video out, I'll put a link in the top right hand corner of the screen. However, if you want to continue to use the auto bed leveling sensor, then put this aside and keep it safe, as we're going to be reusing this part later. In addition to the auto bed leveling sensor, inside of the fan guard is your extruder fan, and that could be held on with 2, 3, or even 4 M3 screws. In this case, it is 2 on my printer, and so I'm going to undo those, and that'll allow me to remove the extruder fan. Then you can carefully wiggle everything out of the fan guard, and in my case, since I'm not reusing the auto bed leveling sensor, I'm going to be pulling that right through the wiring harness and removing it completely. And again, if you plan on reusing yours, or if you have one at all in your printer and you want to keep using it, then you can just leave it be. At the back of the printer, the Bowden tube setup is there, and we're going to start disassembling that. You'll also see that I've unplugged the stepper motor. So most of these Bowden tube setups, with the drive unit being back there, they take on a very similar shape. On the ET5X, this is what it looks like. On your printer, again, it may be, ever so slightly different, but more or less it should look like this. And so the drive gear and tensioning setup is usually held on with 3 screws. They're usually all M3 screws, and those go directly into the stepper motor. So you're going to just unthread those, and that whole assembly should come off, and the stepper motor will fall down. So be sure not to let that stepper motor fall onto your glass build plate. You might crack it. And make sure your spring doesn't pop out and fling out across the room. Although you're not reusing this piece here, again, you just don't want to lose it. With your extruder motor removed, you can now remove the hob gear, and that's also usually held on with 1 or 2 grub screws. So you can go ahead and loosen those off, and that gear should slide off the motor shaft. Now I'm going to remove the printhead carriage, and you can start by slipping the belts off. If the belts are really tight and you can't get them off, you may have to loosen off your tensioner if you have a belt tensioning system on your printer. Otherwise, mine were good enough to just slip off. Then you can simply remove a few of the V-slot wheels, and that should be enough to get your printhead carriage off of that piece of extrusion. Just remember that your bottom V-slot wheel is usually the one with the eccentric nut, and so you're going to have to hold the locking nut on one side and unscrew the button head cap screw on the other side in order to get this V-slot wheel off of the carriage. Now we can take 2 of our V-slot wheels and install them on the top 2 positions of the Micro Swiss machine plate. Now the kit comes with new hardware, which I would highly recommend using because it is probably of higher quality than your cheap Chinese printer hardware. When you tighten these button head cap screws down, make sure you don't go too tight, as you don't want to crush the bearings. You just want it tight enough that there's no wobble in the V-slot wheels. The bottom V-slot wheel will accept the eccentric nut, and make sure you put that eccentric nut in the correct orientation. So there's a little boss that sticks up off of it, and that's going to go into the hole on the x-carriage plate. Now you don't want to tighten this down at this point too much because you won't be able to slip it onto the 2020 extrusion. So you just want to hand thread on the nut enough that you can wiggle the whole assembly onto the extrusion and not have that bottom wheel interfere so that you can't get it on. Once it's back and sitting on the extrusion, you can hold the nut on one side and screw in the other side to lock that bottom V-slot wheel into place and secure the whole X-carriage onto the aluminum extrusion again. Now you can make any sort of necessary adjustments to your eccentric nut to get your carriage moving smoothly across the extrusion without any play or wobble in it. One other thing to be mindful of here if you're installing this kit on a printer that it was not designed for is to make sure that your x-carriage is square with your extrusion. And so you see me checking it here with a square, and in my case this was not originally the case. And this is because the thickness of the eccentric nut on my ANET printer is not the same as it would be on the Creality printers. In order to get the carriage squared up, we'll take a look at this clip here, and you'll see here where I've added some washers between the V-slot wheel and the eccentric nut, and that's going to space out the V-slot wheel enough to square up the carriage. At this point, you should be able to mount your belts onto the Micro Swiss carriage, and they slip in the same way as they did on the old carriage. Now keep in mind here that if you did have to loosen off your belts and loosen off the tension, you're going to want to reapply the tension to your belts. If you're new to 3D printing and you haven't dealt with belt tension before, 3D printers don't need a lot of belt tension. It just needs to be taught. Don't overdo it because you don't want to stretch the belts. They're not very big, and again, they don't need a ton of tension. The stepper motor mounts to the carriage using 3 M3 countersunk head screws. Make sure that your connector is facing upwards, and if you have thread locking compound, you're going to want to use that on these screws. They're going to be subject to a lot of vibration, and you don't want them to come loose in the future. You'll see that the bottom right hand hole is left empty, and you're not putting a screw in that yet, so we'll get to that in a minute. The filament tensioning arm gets mounted to the carriage plate using the precision shoulder screw, and so that's going to slide through the empty hole there in the bottom of the tensioning arm, and that's going to get screwed into that empty hole that we left blank when we attached the stepper motor to the carriage plate. So you'll see that here. With the shoulder screw tightened down fully, the lever arm should be able to rotate freely. However, I experienced some amount of friction between those two parts, which to me would indicate that the part was potentially machined incorrectly. I added some thread locker to the thread on that shoulder screw, and I had to back it off just a little bit, and to this day it's never come loose, so for me that was good enough. Now you can slip a piece of filament in through the top, and this is going to help you center your drive gear. And so you can see that the idler gear is just sitting there on the tensioning arm, and you have your drive gear with the grub screw or set screw. We're going to make sure we align that set screw or grub screw with the flat portion of the shaft, and we're going to slip that in just like this. And those gears should, once you get it past the filament, the gears on the drive gear and the idler gear should engage with one another once you press the tensioning arm back towards the drive gear. And once you get those sufficiently centered, you can tighten down the grub screw on the drive gear. Give the gears a spin by hand or pull up and down on the filament, and make sure the engagement of those teeth is smooth. The tensioning spring and knob goes on next, and it just slips through the slotted hole above the extruder drive gear, and the spring slips on top of that. The adjustment knob goes on the other side of the adjustment arm, and the starting position for the tension should be such that the thread going through that adjustment knob will just sit flush with the end of the adjustment knob. Apparently this is a good starting point for PLA. If you're using a softer filament like TPU, then you may need to reduce the tension on the tensioner by unscrewing the adjustment knob. Moving on, we're going to take a look at the heat sink, heater block, heat break, and nozzle. And so the heat break slips out of the heat sink, and we're going to be threading that into the heater block. So it's going to thread in on the opposite side of the heads of those socket head cap screws, and you can just start by threading it in by hand, and then you can use the included tool to snug it down. These are fairly small parts, so don't go too crazy with the amount of torque applied. Before threading the nozzle into the heater block, I always like to apply a little bit of thermal paste. This was not included in this kit, but if you've been assembling and disassembling 3D printers or even computers for a while now, you're going to want to take a look at picking up some of this thermal paste. Now you only want to apply just a little bit, and you're going to hand thread in that nozzle. Definitely don't thread it in starting with using any sort of tools. Do it by hand. You don't want to cross thread any of these threads. I like to run the nozzle in and out of the heater block a few times to distribute the thermal paste, and if you find you've added too much, you can wipe away the excess. Try not to get any into the actual melt chamber because you don't want to contaminate your filament. Using the included tool, you can now snug up the nozzle. Again, don't go over tight here. Now you can slip the heat break into the heat sink, and you can set that on a flat surface to align the two parts and use the included grub screw to tighten those two pieces together and get them into their final position. And I know I keep repeating myself here, but do not over tighten these parts. Now you can insert the included piece of PTFE tube into the hot end, and you can see at the top on one side there is a notched portion, and that notched portion is going to stick out of the hot end. So just force that in as far as it'll go. Take your hot end assembly and bring it over to your carriage. You're going to be inserting the PTFE tube first into the bottom of the PTFE tube receptacle. The notch in the PTFE tube will line up with the gears. It's a little difficult to get that on camera, but you may need to just twist your PTFE tube around a little bit to get everything to align. Once you get the holes lined up to mount the hot end, you can now take your M3 by, I believe they are 20 socket head cap screws that were included in the kit, and I've added a little bit of thread locker to them, and you're going to fasten down your hot end to the carriage plate. Before installing the heater cartridge and thermistor back into the heater block, I'm going to get the thermal paste back out and I'm going to apply a thin layer to both of these parts. And again, if you're new to this concept, the idea here is that the thermal paste is going to help uniformly distribute the heat between the parts. All of these parts have tolerances in their manufacturing, and the heater cartridge, for example, may not be making contact to the heater block across its entire surface. And so this is just going to help transfer the heat better between those parts and take up any small gaps between the two parts. Once you get the heater cartridge slipped into the heater block, as well as the thermistor slipped in there, suspend your wiring harness above the extruder assembly such that the wires going to the heater cartridge and thermistor are not being pulled on while you tighten down the socket head cap screws that go into the heater block, and this is going to lock the heater cartridge into place. Make sure that your wires on your heater cartridge are pointing up towards the top of the assembly, and this is how they're going to be routed later on. You can also now put the screw back in holding in the thermistor. Do not over tighten this as it will crush and damage the thermistor wires. At this point, I noticed one new problem for my application, and the blue bracket here you can see is contacting the stepper motor on the direct drive unit, and this is preventing my printhead from ever reaching my X limit switch, and so I'm going to have to do something about that. I've marked off this area that I'm going to have to notch off this bracket, and it's about 45 millimeters long by about 20 millimeters high, and so I'm just going to use an angle grinder and just do a little slice and dice here to remove this piece. After carefully slicing away at the bracket, you can now see that the stepper motor clears. However, looking at the bottom, it turns out that the carriage plate still does not make contact with the X limit switch. I've removed the limit switch from the machine, and the most obvious solution to me would be to just space out the limit switch away from that plate so that it makes contact with the extruder. However, taking a look at the hardware, there's not a whole lot of thread left on there, and so spacing it out would mean that I would need new hardware. In this case, I didn't have any longer M2 bolts laying around, so instead I came up with this little limit switch extender slash paddle, whatever you want to call that sort of thing, and it just slips over top of the limit switch and gives me a little bit of extra distance in the other direction, and that's going to be just enough to contact that extruder carriage. And with it mounted back on the machine, you can see here that it is in fact working. The next obstacle I ran into was mounting the fan shroud or fan guard, whatever you want to call it. And so this again was designed originally for a Creality printer. However, my ANET fan guard is slightly larger, and that's due to the fact that the hot end of the ANET is larger than the Creality hot end. And so you can see that the Micro Swiss hot end mimics the size of the Creality hot end. This is, of course, was its intended application, but mine is longer, and yours might be too if you're installing this on an ANET machine or maybe some other Chinese brand. If you can get your hands on a spare Creality fan shroud, you can just go ahead and use that. I happen to have one, however, that really wouldn't help you guys out if you couldn't get your hands on one. So I went and designed some new parts for this extruder. The new parts that I designed can be seen here in red and purple. And so in the foreground, you can see the red fan guard, and in the more background, you can see the red fan shroud. And this is also what everything sort of mounts to here on the x-carriage assembly. In purple, you can see the part cooling fan duct on the bottom. And I've tried to work in the Micro Swiss logo into these parts just for fun. On the top of the purple part, you can see where the part cooling fan duct would feed into the fan duct, and I've brought back the part cooling fan now so you can see that. And on the back, you can see where the red fan shroud actually hooks on to part of the carriage. So it's not fastened there, but it hooks on for a little bit of extra support. On the bottom, you can see the individual outlets for the fan duct. You can also see where the original bed leveling sensor comes through the fan shroud. Looking at this from the top, I've tried to leave plenty of room in there to get any tools or your fingers in there if you have to service or access anything if need be. And also off to the side, you can see that I've put a provision in there for using some zip ties to secure your wiring harness coming out of the hot end to provide a little bit of strain relief for those wires. And so you're going to need a 3D printer to print these parts. So if you have not yet disassembled your printer that you're working on, you can print them ahead of time. Otherwise, you're going to need a second printer. I would highly recommend printing in a higher temperature material, as PLA will likely melt next to the hot components. Right now I'm showing how the original auto bed leveling sensor mount would mount to the fan shroud using the two M3 screws on the side, and there's still a little window there to access the grub screw that would set the position of this sensor. And so if you are not using this sensor like myself, and I've replaced that with a mechanical switch, you can just go ahead and completely ignore adding this to your assembly. So I'm going to remove mine. Of course, like I said, I just wanted to show you guys how it would mount if you are continuing to use that sensor. Next, you're also going to want to run through some of your screws to tap threads. And so in some cases, you can tap the threads with the screws themselves, but I would recommend doing this off of the printer. It's a lot easier to do when that part is not already mounted to your printer and you can just do it in your hand. Otherwise, if you have a proper drill and tap set, I would highly recommend using that, as it cuts into the plastic a lot easier and puts a lot less stress on the parts. And so we'll start by doing a little pre-assembly, and we're going to grab the fan duct, and we are going to take a M3 by 12 socket head cap screw, and we're going to push that in through the bottom, and you're going to just have it stick out the side there, and that's going to be easier to mount to the fan shroud. Now, as I had mentioned, I'm not using my auto bed leveling sensor, so I also designed a little plug to plug that hole. I'll put design files up that also have the hole completely eliminated. So if you accidentally print one with the hole and you don't need it, you can plug it. Otherwise, you can just print the version that does not have the hole at all if you do not need that. And I'll make all of those files available in the video description down below, so go check that out. Once you have that taken care of, you can now mount the fan duct to the bottom of the fan shroud, and we'll start by screwing in that one single M3 screw. And that'll be enough to just hold it in place so that later on, once we go to install this on the actual printer, it's easier to handle this thing and it won't be falling out of your hands while you're trying to mount the part cooling fan. Now you can bring your fan duct and shroud assembly over to your printer, and you can begin to assemble it onto the Micro Swiss carriage. And so you can reuse the original M3 socket head cap screws, and those should fit into the two most outer holes on the Micro Swiss carriage. And so you can see here, I'm also just fiddling around with the fans a little bit as I'm trying to get the wires out of the way and not press on the heater cartridge wires or thermistor wires because again, I don't want to break those. Then I've reinstalled the original part cooling fan with the original 3 M2 screws. The 2 bottom ones were longer than the top one, so just keep in mind that your printer might be the same because those 2 bottom screws have to go through the fan duct as well. The wire for the part cooling fan is routed in and behind the fan shroud, and that goes up into the wiring harness and up and out towards the control board. Now we can also reattach the extruder fan and the 3D printed fan guard, and these parts here are going to be attached right now temporarily with a single M3 socket head cap screw, and I believe the length that I used here was at least 15 millimeters long, maybe even 20 millimeters long. There's plenty of space in the fan shroud for extra length on your M3 screws, so it will accommodate longer screws if you don't have access to a large variety of different lengths. For now, we're leaving in the single screw, and this is going to allow us to rotate the fan and fan guard out of the way so we can access the grub screw on the front of the hot end that tightens down the heat brake, because we're going to have to go through and retighten a lot of those fasteners after our initial heat up of the hot end. With all the major parts now in place on the printhead, you can now take your wire bundle and secure it to the fan shroud with a single zip tie, and this is going to provide that strain relief on the heater cartridge and thermistor and hopefully keep those wires from ever popping off. Now is the time to install the filament and PTFE tube guide, and it gets mounted to the original holes where the extruder motor was mounted. Now in my case, I also have a filament runout sensor, and the part included from MicroSwiss does not align nicely with the filament runout sensor. If you don't have a filament runout sensor, then you may not have any other point of entry for the filament, and so you don't have any concerns and you can use the original MicroSwiss part. However, if you need to create a new part, I've already done that for you, and if you're using an ANET printer, the alignment will be perfect. If you have a different printer that you're trying to adapt this kit to, then you can try my part out and hopefully it works for you. But I've reconfigured this part to fit and align perfectly with the filament runout sensor. To use the new part, you're going to remove the retaining clip from the original, and you're just going to simply pull out on the black PTFE tube plug, and you're going to push that into the new part, and it should just pop right into place. And you can put the retaining clip back in so that you don't lose it. 2 M3 button heads included in the MicroSwiss kit hold this into place, along with M3 nuts on the bottom. MicroSwiss includes non-nylon locking M3 nuts, but if you have nylon locking M3 nuts, I would prefer to use those over the non-locking version. Now we can revisit the wiring, and you can see that I've taken my hot end wiring harness, routed it in through the original hole where the extruder motor used to be, and I've plugged in my connections back into that intermediate board. Again, if you don't have one of these intermediate boards, you're going to have to go right back to the control board and plug everything back in. I've secured the wiring harness down with a zip tie. Those holes there in that mount were intended for zip ties, but when I was trying to use them, it would interfere with the PTFE tube, and I didn't want to do that because it would create more friction in the filament path. And so you can see here how I've taken my PTFE tube and secured it to my wiring harness, and those zip ties are not that tight. You don't want to over tighten them, as again, you don't want to create friction in the filament path. We'll take one more quick look from the front of the machine, and again you can see the routing of the PTFE tube and wiring harness. And one final thing to do here on the PTFE filament tube is to put in the retaining clip. And so MicroSwiss includes this metallic retaining clip, and it's just a circlip. It inserts into that slot there, and that's going to bite into the PTFE tube and prevent it from getting pulled out. Plug your printer back in, turn it on, and preheat your nozzle to at least 240 degrees Celsius. Let it sit at this temperature for a minute or two, and let the heat soak and saturate into all the parts, and then we're going to do a final tightening of all of the hot end parts. Starting with the heat brake grub screw, you can gain access to it by rotating the extruder fan out of the way. Give it a quick little tighten. Don't keep that Allen wrench on there too long, as the heat will eventually make its way back to your fingers. Then you can put the second M3 socket head cap screw back into the fan guard, and that is going to prevent that from rotating out of place during printing. I designed the fan ducts and shrouds to retain easy access to a lot of the hardware on the hot end, so that during this procedure or other common service tasks, you don't have to take those parts off. And so right here, I'm just tightening the 2 socket head cap screws that hold in the heater cartridge in the heater block. And again, this is with the hot end at 240 degrees Celsius, and this is the final initial tightening after the initial assembly. The nozzle is the final component to tighten, and you're gonna wanna hold the heater block in place while you're doing this, otherwise you'll put a lot of stress on the heat break. So using an adjustable wrench, you can hold the heater block and then just give a very light tightening to that nozzle. With all of your parts now tight, you can let the hot end cool down. Make sure you don't do this hot, otherwise you'll burn your fingers. But now you can install the heater block sock. Now there's a high likelihood that your new nozzle does not sit in the same position as your original, and so we're going to have to adjust our home offsets. And I like to do this by measuring off my work surface first, so the print bed, and in this case on my ET5X, it's 300 by 300. And so I'm going to make a mark in the center of the bed at 150 millimeters in the X direction, and I'll make another mark in the Y direction at the midpoint here, which is again 150 millimeters. Now you can home your printer, but before doing that, be sure that you don't need to make any adjustments to your Z end stop, because you don't want your nozzle crashing into your build plate. In my case, my new nozzle actually sat higher than my old nozzle, so there was no risk of this. In the home position, you can see my X and Y offsets on the readout. If your printer does not have an XY position readout on your screen, then you're also going to want to have your printer plugged in right now to a printer host like Repetier host, Pronterface, or even Octoprint. And because you're going to be eventually feeding it some G-code commands, but for now, I'm going to be moving using my screen. I'm going to make some rapid moves to Y150. So this is the halfway point that I marked on my bed, and we're going to see how it lines up on the print bed. And so now you can see the printer thinks it is at Y150, but in reality, it's about 15 millimeters short. And so I'm going to have to change my home offset from -17, and I'm going to subtract another 15 millimeters, and my new home offset will be Y-33. So we're going to have to change that using G-code. Now you can home your printer again, and you can check that you're back at the original Y offset. And then you're going to go into your G-code terminal, and you're going to type in G92, Y, and then your new offset value. And your printer should now show the new Y offset value. And so what the G92 command does is it forces your printer to accept your current position as the new home position with the value that you entered. And so now if I return to Y150, you can see that my nozzle lines up nicely with the midpoint on my print bed, and you can do the same procedure for the X-axis. Keep in mind that these new values entered using the G92 command are not permanent. They're not stored in the EEPROM memory, and the next time you start your printer, or even you go to the next print job, and the printer will have forgotten these. If you're not willing to, or you cannot modify your firmware, in this case, like in my case with the ANET printer, the firmware is fairly locked down and there's no bootloader, so I can't just simply upload a new version of Marlin. With these home offsets hard-coded into the firmware, now I'm going to have to do this every single time I start a new print. Now you can do it manually, or you can put this in your start G-code in your slicer, and I'll show you how to do that. Now I personally use Prusa Slicer, but you can do this in Cura and most other modern slicing softwares. And so you navigate over to the printer settings, take a look on the left hand side in Prusa Slicer, and you'll find custom G-code. Over here you can enter a custom G-code script that will run at the start of every print, and so that's under start G-code. And if you take a look down where you'll find a G28 command, which is the auto homing command, you'll see what I've done here. And so the G28 command will home all of the axes one after another. But in my case, where I've had an auto bed leveling sensor, When it goes to home the Z axis, you'll notice that the printer homes itself on the Z with the printhead in the middle of the print bed. Now this becomes problematic when you're trying to set new home offsets, because if you set that after a simple G28 command, then the middle of your print bed is going to be your new printer origin. I don't want this to be the case because in all of my slicing software, I set my printer origin in the bottom left-hand corner of my print bed. And so what I've done here is I've set the G28 command with XY. And so this is going to home the X and Y only. Then I can insert my G92 with my custom offsets for home. And then I can say G28Z, and then it'll home the Z axis. This is going to maintain the bottom left-hand corner of my print bed as the new home origin with those offsets. Now every time I slice parts using this profile, this command will run automatically at the beginning of every print, and I don't have to set my offsets manually. In addition to making changes to the home offsets, you're also going to have to change the extruder steps per millimeter. And this is because you've made changes to the filament drive system, and so you can see the new extruder gear here, and you can see the old one in comparison on my ANET printer, and you can see the size difference. So the old one is larger, and this is going to require less steps per millimeter to extrude the same amount of filament. Now to change your E-steps, there are several different ways to do this, and you can hard code it again by changing your firmware if that's an option. And if it's not an option to change it in your firmware, you can do this in the G code as well at the beginning of each print to temporarily change these settings. Or in my case, where this didn't seem to work whatsoever, there's a third option which we'll get to eventually, but first let's explore the G code option. So we're just taking a very quick look at a notepad file with some simple G code in it, and I'll explain to you what these commands will do and how we can eventually change our E-steps using this method. And so if you type into your terminal, again, you can do this in Octoprint or Pronterface, some sort of terminal that has been connected to your 3D printer through your USB cable. If you press or enter M503 and just hit enter, no semicolon necessary. That's just indicating it's a comment. Anything after the semicolon is a comment. So M503, and it's going to show the printer settings, or it should show them at least. So if your printer is running a compatible version of Marlin software, it will show some of those settings, and hopefully it shows you the steps per millimeter for each axis. And if it doesn't, you can try the M92 command. And again, just M92, hit enter, and that should show the motor steps per millimeter in the X, Y, Z, and E being your extruder. In my case, it did not do this whatsoever. Neither command worked for me, but if you're lucky enough that it does work, then you can type in M92, E130. And this, by passing it this E130 parameter, you're going to be telling your printer to set the E-steps to 130. And this is what is recommended in this kit from MicroSwiss right from their website. And it's a good starting point to start to calibrate your E-steps. Now there's a lot of videos online on how to calibrate your E-steps, and so I'm not going to take you through that procedure, but this would be the starting point. Then after you got your starting point, you can set that to the memory, so the EEPROM memory, and that's simply done by hitting M500 and pressing enter. And that should store your settings to the memory so you don't have to do this again. Now if you find that your printer accepts the M92 command to assign new E-steps but does not accept the M500 command to write those to memory, then you can come back to your start G code, and up at the top you can enter M92 E130, and that is going to set those E-steps at the beginning of every single print to make sure that you have your E-steps calibrated for each print. Now in my case, because my printer did not even accept the M92 command, I'm going to get rid of this. And my last resort to making this change to calibrate for this extruder is to go into my filament settings and change my extrusion multiplier. Now, this is not really the best way of doing it, but it effectively does the same thing. The extrusion multiplier just takes your E-steps and multiplies them according to the multiplication number that you have put in. And so again, it's not really the preferred method, but as a last resort, like in my case where I cannot modify this firmware. This did work for me, and in my case with the ANET ET5, 1.25 was the magic number. Now the final issue you may run into is that your extruder is running backwards. Now in this case there are two solutions. There's a software solution and you can change the direction of the extruder in the firmware, but like me, if you cannot modify the firmware, then there is a simple hardware solution. So what you need to do is you need to unplug the connector on your extruder, and we're going to be swapping two wires on the plug, and the two wires we're going to swap are two wires that are assigned to the same coil. Now the stepper motors have coils inside, and you can test to find two wires that are connected to the same coil by getting out your multimeter, setting it to the continuity setting, and prodding your connectors, or prodding the pins coming out of your stepper motor. And if you find continuity between two pins, that means that those two pins belong to the same coil. So just swap out the pins on your connector and then plug it back in. And you're just going to need to do this on a single coil, not both, and you'll get your motor to run in the opposite direction without changing the firmware. After all that, you can finally get into laying down some plastic. Now I'm printing in 3D Max's PLA Plus here, and I recently did a review and setup guide for this filament, so you guys can check that out. I'll put the link in the top right hand corner of the screen if you're interested, of course. And I'm now very familiar with this filament and the required setup parameters for it, and so it didn't take me very long to get this dialed in. And once it's dialed in, this is a really nice looking, vibrant colored filament. And I started by printing the typical benchies, calibration cubes, and temperature towers to make sure that I had this filament really dialed in. In addition to calibrating your filament, you may also want to run a PID auto tune, and there's lots of videos on YouTube about how to do that. And that's of course for your new hot end, so you keep a nice tight temperature profile. All the parts that I've printed with this new direct drive extruder have come out really clean so far. I find that the direct drive meters the filament better than the old Bowden tube setup. It wasn't bad before, but now it's really exceptional, and all the small details, even on this benchy, came out really, really nice and sharp and clean. That small hole in the back of the boat is excellent. The little smokestack on top is exceptional and really, really tight and clean. This is probably one of the best benchies that I've printed on at least my personal printers. Things like the calibration cubes came out really nice and clean. All the letters were sharp. Dimensionally, they were very accurate, within 0.1 millimeters or less. And this is another part just with a fairly large unsupported bridge here, and that came out nice and clean. Bottom and top infills were really excellent, and no signs of under extrusion across the sides of the parts. Layer lines were barely visible, so it is performing excellent, and I'm quite happy with this new setup. So that's it for this installation and video. I hope you guys found it useful and easy to follow along. If you have any questions, please put them in the comment section down below. I try and get back to every single person. And if you have any feedback about these videos, that goes in the comment section as well. If you're looking for the design files, they're in the video description. Other than that, thanks for watching, and I hope you guys decide to check out some of my other videos.